All right, guys, happy Monday. Sorry I can't be there with you today, but we're going to do independent events, which is the and of probability. And we've talked about this a little bit, so hopefully today's stuff nice and easy. We'll clean it up tomorrow. But go ahead and make sure you find your notes. And we're looking at, if you flip a fair coin, what's the probability that it lands on heads? So again, we've done this quite a few times. You've got two possibilities. The probability of heads, it should come up in a theoretical sense, 1/2. Okay, and again, in pre-AP, we can say that, the same thing. It could be the 0.5, either one. And if we roll a standard 6-sided die, the probability that it would show a 5. So again, my notation, that capital P, my 5, well, there's 1 out of a 6 chance that that would wind up on a 5. So again, just for the sake of what we're going to head to next, I'm going to leave it as a fraction. So what we're looking at today is, okay, well, what happens if I start looking at multiple events at once? Okay, so what happens if I flip a coin and I roll a 6-sided die? Let's take a look at how we could calculate those probabilities. So we're going to start with organizing our sample space. So again, remember that our chart, great method for organization, so is that tree diagram, but our sample space officially, remember that gets listed out a little bit differently. So let's go ahead and fill this in first. So my probability of a heads and a 1, again, I would just write that as a heads and a 1. Heads and 2. I could roll a heads and a 3, heads and 4, heads and 5, or heads and a 6. And then I could do the same thing with the tails. So tails and 1, 2, 3, 4, 5, or 6. So remember, I can use my chart. That's a great method for organizing. But remember that sample space, just so we have it. My sample space then would be heads 1, heads 2, heads 3. Now again, I can write these in any order. That's not the important part. But remember that when I'm listing them out, I'm separating each element with a comma. And then we talked a little bit about that my sample space was going to be a set. And so we use the set notation. And all that really means to you is that you've got those squiggly brackets on the end as best you can. All right, so this, again, the chart, that's going to be how I organize, how I can make sense of it. But specifically, if we ask you for a sample space, remember that the mathematical sample space is where I list each element, I put a comma in between, and then I've got that set notation on the end. All right, so if we look at the sample space, remember on a chart, something like this, if I want to look at where the and happens, what I'm looking for is my overlap. So if I flip a coin and roll a 6-sided die, the probability that we land on heads, so again, I would be looking in this one, and that it shows a 5, I would be looking in that column. So my and is the overlap. So the probability of heads and a 5, remember that was my notation for and, that would be a 1/12. Okay, so part of what I wanted to do when we left it as a fraction, that's what we're going to notice down here. So what we're noticing is the probability of the heads and 5, that 1/12. I could have also found that by taking the probability of heads, which was 1/2, and multiplying by the probability of getting a 5. And so remember when we do fractions, I just go straight across. So numerator times numerator and denominator times denominator. So what we're noticing is we could have found it either way. Now, there's nothing wrong with doing that chart, but again, it can get pretty tedious as our sample space gets larger and larger and larger. So what you're noticing today, independent events, that's our new vocabulary word. Independent just means that whatever I did the first time has no impact on the second time. Okay, so if I flip a coin, no matter what happens, that does not impact that dice, not at all. And when that happens, again, we call them independent. And so our new formula is right here. The probability of A times B should be equal to the probability of A and B. Now again, that's only if events are independent. And so you'll oftentimes in pre-AP specifically, they will refer to this as the multiplication rule. So our first formative check, I'm not trying to trick you. Your first formative check, they're going to ask you to use the multiplication rule to prove independence, and then they'll ask you to use what we're going to learn tomorrow, the conditional probability rule, to prove independence. So it's going to be super important. This one you need to know. Again, pre-AP does not give formulas. OST will. This is a formula given on the OST, but again, you're going to go ahead and memorize it because you are a pre-AP student. All right, so let's take a look at that first example down here. We're going to use the Venn diagram to determine if being in band and being in choir are independent or whether they're dependent events. So if they're not independent, by default, they would have to be dependent. slide that up a little bit. Okay, so a couple things I'm noticing. There is no none given, so we're going to assume that our none would be a 0. If nothing's listed, we don't have a total, we're going to have to assume that the none was 0, and so we'll go ahead and figure out what that total is. So when I want to find my total, I'm just going to go ahead and add all of those values together. So if you've got your calculators, we'll check that real quick. Pretty sure it's 625, but yeah, just making sure. All right, so our total is going to be a 625. So if I'm going to use my new multiplication rule, what I would have to prove then is the probability of band, so I'm just going to use a B for that one, the probability of band times the probability of choir. Is that the same as the probability of band and choir? That's what we're curious about. Sorry, let me straighten that up. All right, so the probability of band, let's go ahead and find that. The probability of band, now remember, when I want to find band, that's everything in that whole circle. So it's not just 250, it's everybody in band. All right, so that should get me a 400 out of 600. Which would reduce down to a 2/3, which would be a 0.666, and then it would round to the 7, right? So 6 repeating, anything higher, we would round up, so that would give us that 0.66. I'm so sorry, as I looked at that, it should be over 625. Let's fix that, guys, sorry. Let's fix that. That should be 625. I was like, I don't remember that number. There we go, let's try again. Okay, so if we do 400 divided by 625, sorry, that should come out to a 0.64. So reduced fraction would be 16 over 25 if we want it. I apologize. There we go, 0.64. All right, and then if we check the probability of choir, let's see if I can get the right denominator this time. So choir, again, would be anything in this circle. So 225 plus that 150 should come out to a 375, also divided by 625. So 375 divided by 625. Reduced fraction, that should be a 3/5. As a decimal, should be a 0.6. Now, on our Venn diagrams, remember that when we want to find our and, the and is the overlap. So that would be this piece right on that inside there. So the probability of band and choir, sorry, shouldn't have crossed that. Sometimes I do that just to remind myself, but we'll make the notation appropriate. That would be a 150 over the 625. All right, so let's see what that reduces down to. Again, as a decimal, should be a 0.24. If I change it to a fraction, just so you've got it, it should be 6 over 25. And then just in case, remember that if we want to change it to the fraction, so if I took the 150 and I divide by 625, just as a quick review, if I want this as a reduced fraction, right, remember that the key I'm going to press is math, so that's the one, regardless of what your calculator looks like. Third one down on the left. I want that fraction key, so I'm going to press enter, and then one more time. So just as a reminder, that's how we're going to convert those fractions. Okay, so we have all of our individual probabilities. So the question becomes, is, when I multiply the 0.64, right, so the probability of B multiplied by the probability of C, which was my choir. So is 0.64 multiplied by 0.6? We're going to see what that is. Does that equal the 0.24? That's what we're curious about. So 0.64 multiplied by 0.6, that's going to come out to a 0.384. Well, 0.384, right, if we look at it, 0.384 does not equal 0.24. Therefore, our events, are dependent. Okay, our probability rule did not hold. If it doesn't, again, my only two choices are independent or dependent. If this rule doesn't hold, then it has to be dependent. All right. All right, let's go ahead. Let's flip that paper over. Okay, so as we look at the back, same idea. So your table, again, already filled in for us. So I'm going to go ahead and call it, just for ease, I'm going to call this one capital A, just we're participating in the after school. This one is not going to participate. And then we'll do female and male, so F and M. All right, so same idea. We're still just going to practice using that rule. So R, being a female and participating in after-school activities, independent events. That's our curiosity. So again, in order for that to be true, the probability of female multiplied by the probability of after-school events, that should be equal to the probability of female and after-school events, right? So if they're independent, that rule has to be true. So we'll find our individual probabilities first. So my probability of female, all right, so if I look over at female, that would be 580 over 1,000, okay, which should come out to a 0.58. Again, I think sometimes decimals are a little bit easier, but whatever makes you happy. Probability of after-school athletics. So again, if I look down on my after-school athletics category, that's going to get me that 400. Again, also over 1,000. And so when we divide that one out, that should come out to a 0.4. You can throw a 0 after it. Again, you never have to force zeros. And then if I look at the probability of female and after-school athletics. So again, what I would be looking at is my overlap. So ands are the overlaps. So female, that would be this row. And then after-school athletics, that would be that particular column. And so my overlap would be at this 232. So I would have 232 over 1,000, which should come out to a 0.232. And so now we plug it into our formula and see if it's true or false. So if I plug it in, is 0.58 multiplied by 0.4, does that equal 0.232? All right, so if we punch that one, 0.58 multiplied by 0.4, they are the same. So 0.232 equals 0.232. Because my formula holds, I can say that they're independent. Okay, which means that there is no bearing on one another. It makes no difference whatsoever. Male versus female does not impact who's involved in the after-school programs. Okay, so same idea. We're going to do the same thing for the next one. Are being male and participating in the after-school athletic independent events. Now, we would kind of expect them to be if the female was, but we're going to run the math to prove it. So again, if it's true, the probability of male multiplied by the probability of after school, so that would be the after school one, should be equal to the probability of male and after school. If it's true, that's what should happen. So let's check them again. So probability of being male. All right, so male would be 420 over 1,000, which should come out to a 0.42. Probability of after school athletics, we just did that one, so that was the 400 over 1,000, which should be a 0.4. And then the probability of male and after school. Okay, so again, if I look at male this time, let me find a different highlighter. All right, so here's male and after school, so it would be the same column. So now I'm looking at a 168. So 168 over 1,000 should come out to, again, 0.168. All right, so we plug it in to check. So is 0.42 multiplied by 0.4, does that equal a 0.168? So if we check that real quick, 0.42 multiplied by 0.4, absolutely. And again, it should make sense to us that they should be the same thing, right? If female was independent of after-school athletics, male should be as well. But again, you have to prove it. If it would ask, so this one it just says, are they independent? So we could say yes. If they asked you to explain, we would just say because, and we can cite our rule, right? So because the probability of the males, multiplied by the probability of after-school activities is indeed the same as the probability of the overlap. Okay, so if PreAP were to ask you for your reason, explain your reasoning, you are more than welcome to cite the rule. That's perfectly fine. Okay, so last one, we're going to fill out the contingency table together. So we'll make sure we remember how to do that. And then once we've done that, determine if having asthma and being in a household where at least one member smokes is independent or dependent. So that's going to be our goal. All right, so when we start, 937 people were surveyed. So that's going to be our total. 937 is going to go right over here in that total. 182 had asthma. So again, here's my asthma. I'm going to call this one an A. This one can just be the N, does not have asthma. We'll call this one, none of them, no household members that smoke, and we'll call this one L, that at least one does. Excuse me. Okay, so a student that has asthma, that should come out to 182. Then we've got, so we've done this one, 542 live in a household where there are no smokers. So household with no smokers, that would be right here. Here's your 542. That one's done. Then we've got 69 students have asthma and no one smokes in the home. All right, so we're looking for the overlap, right? Anytime you see and, you're looking for the overlap. So students that have asthma would be this one. So again, if I just kind of highlight that, student that has asthma would be in this one, and no one smokes in the home, that would be this one. So my overlap would be right here. And now we've got enough that we should be able to fill in that table with a little bit of subtraction. So if I start in this particular column, 542, get rid of that 69, I'm going to have a 473. If I want to find this one, I can go across. So again, if I start with 182, again, get rid of the 69, I would have 113. I can subtract here to go ahead and find that one. So 937, get rid of 182. Here's my 755. I'll subtract again. So 755, get rid of 473. Should get me the 282. And then again, I'm either going to add or subtract. Sometimes it's a nice way to check them is to do both. Oop, 282. So I should get a 395. And if I go ahead and subtract, just to double check that, 937 minus that 542 is indeed at a 395. So there's your, again, contingency table. Remember, contingency is counts, so that's your whole number. It's the relative frequency, right, where I would divide all of those things up, which you could do, but they didn't ask us to. Okay, so the question was, back in the beginning, determine if having asthma, so is the probability of asthma, and is multiplication, at least one member smokes. Yes, so probability of L. We're curious, does that equal the probability of asthma and at least one member smoking? That's the curiosity. So if it's true, they're independent. If it's false, it's dependent. So let's find each one. So the probability of asthma would be a 182 over 937, which should come out to, 182. Okay, so if we round it out correctly, 0.1942. All right, and then if I check the probability of at least one person smoking, again, that total, I would follow that down. So that's going to be a 395 over 937. So rounded correctly should be a 421. Now notice, here's my fourth place out. The digit next to it is a 5. If it's higher than 4, I go up. So 0.4216. Okay, and then my probability of asthma and at least one member in my household smoking. So here's my asthma, right? We already had that in the orange, but here's my asthma. And then at least one member smoking would be here. So the overlap would be that 113. Oh, you couldn't stop. I'm sorry. Let me move that down. There we go. All right, so I would have 113 over 937. And if we divide that out, 0.120. Again, rounding, I've got a 9 here, so I'm going to round that up to a 6. All right, so then we check. So if we plug this in, does 0.1942 multiplied by 0.4216, does that equal 0.1206? I just want to caution, you're being real careful when you write this, that you're either putting a question mark over it or maybe you're just putting an empty box here. It would not be appropriate at this point to put an equal sign, because if those happen to not be equal, that would be a false statement. And again, we don't give full credit for false statements. So you want to be real careful that when you're writing your initial equation possibility, right? That you've either got a question mark, you've got an open box there, something to show that you're not claiming equality yet. All right, so 1942 multiplied by 0.4216, that's going to come out to 0.081, again, rounded correctly would be a 9, which does not equal the 0.1206. Okay, which would mean, in this case, it's false, so this would be dependent. All right, so again, if they had asked for a reason, right, these would be dependent events because my probabilities are not equal. The equation that we had failed. All right, so your goal for today then, right, this is as far as we're going. Go ahead, take a look at the pre-AP worksheet 110A. That's going to be your goal for tomorrow, and we will clean it up there, look at conditional probability, and move on. Have a great rest of your day. I appreciate you watching this, and I'll see you guys tomorrow.